Hello everyone, I'm Samia Hassan from the page Whiteboard, and today I'm going to solve two problems using the integration by parts. And let me start my first problem. So for my first problem, I have integration of ln x whole square dx, and as there are no other terms other than ln x whole square, so I will consider my u to be ln x whole square, and I will consider my dv to be dx. Okay, so according to my formula, I know that integration of u dv is equal to u into v minus integration of v du. Okay, now here my u is ln x whole square, so I will have to find my du, and if I do that, as this is ln x whole square, I will have to use the chain rule of differentiation. If I do that, then 2 will come at first, then I will have ln x to the power 1, and then I will have to differentiate ln x again, and the differentiation of ln x is 1 by x and then dx. So this is my du, and now my dv is equal to dx, and now I need to find my v, and for that I need to integrate dv, and if I do that, I will have integration of dv is equal to integration of dx, which gives me v is equal to x. Okay, so now I'm going to put everything according to that formula, and if I do that, then I will have to multiply u into v, that is I will have x into ln x whole square, then I will have a negative sign according to the formula, and then I will have integration of v du. The value of v is x and the value of du is 2 ln x into 1 by x dx. So this is the value of my du, and now this x and this x will cancel out, and I will have 2 ln x dx. So I will have x into ln x whole square minus integration of 2 ln x dx. Now if I rewrite it, then I will have x into ln x whole square minus 2 integration of ln x dx. Now for this part, I need to reapply the formula of integration by parts again. Now if I do that, then I will consider my ln x as u and my dx as dv. Okay, so like the previous math, my du will be 1 by x dx, and from here I will have v is equal to x. Okay, now I'm going to apply the formula one more time, and then I will have x into ln x whole square minus 2, then u into v, so my u is ln x and my v is x, so x ln x, and then I will have a negative sign, and then I will have integration of v du, and if I do that, then I will have integration of v, which is x, and du, which is 1 by x dx. And now this x and this x will cancel out, and then I'm going to have x into ln x whole square negative 2, then a bracket, then x ln x, and then I will have integration of dx, and then I will have x into ln x whole square negative 2, then x ln x minus the integration of dx will give me x, and then plus c. Now if I multiply negative 2 with this whole thing, then I will have x into ln x whole square minus 2x ln x plus 2x plus c. So this was my final result. So here is my second math, which is ln x to the power 8. So I will have to be careful about one thing. This is ln x to the power 8 and not ln x whole to the power 8. There is a difference between ln x to the power 8 and ln x whole to the power 8. Okay, so what we are dealing with, ln x to the power 8. So as the power is above x, so what will happen, this 8 will come forward and we can write it as 8 ln x. Now if I rewrite this math, then I will have integration of 8 ln x dx, and from this I can take out the 8 and I will have integration of ln x dx, and this math becomes exactly like the last part of our previous math. And here I will consider my ln x to be u and my dx to be dv, and if I do that, my u is equal to ln x, so my du is equal to 1 by x dx, and my dv is equal to dx, and integration of dv is equal to integration of dx, and v is equal to x. And then I will have 8, and according to my formula I will have u into v, which is x into ln x minus integration of v du, and my v is x and my du is 1 by x dx, and then I will have 8 into x ln x minus, and this x will cancel out, integration of dx. Then I will have 8 x ln x minus integration of dx will give me x, and then I will have plus c. Now if I multiply 8 with this whole thing, then I will have 8x ln x minus 8x plus c. So this is my final result.